So today's video is what oxidation product is this? So determining oxidation products of alcohols. So how do we know whether our primary alcohol has oxidized into an aldehyde or a carboxylic acid? Because we know that in excess alcohol it oxidizes to an aldehyde, and in excess oxidizing agent, a primary alcohol oxidizes into a carboxylic acid. So how do we know which oxidation product we have achieved? So when oxidizing a primary alcohol, how do you make sure you get the product you want? How do you make sure you get an aldehyde or a carboxylic acid? So if you want an aldehyde, you first add the acidified potassium dichromate, your oxidizing agent, to the primary alcohol and you distill it. And you can see a distillation apparatus here. So distillation is heating to a temperature in order to evaporate, then condense the product out of the solution. So you're evaporating your aldehyde from the reacting solution, and it evaporates and then condenses in this condenser and forms the product down here out of the reaction mixture. And you do this so it takes the aldehyde out of your solution before it can continue to react with the oxidizing agent further, so it cannot further oxidize into a carboxylic acid. And an aldehyde evaporates first as it doesn't have any hydrogen bonds like alcohols, so it has a much lower boiling point. So we have our primary alcohol and our oxidizing agent heated here. And as our aldehyde forms, it's at a temperature where the aldehyde will immediately evaporate because it has a lower boiling point because there are no hydrogen bonds. So it will evaporate out of our reaction mixture, condense in our condenser, and reform down here. So it's separated from our reaction mixture. It cannot further oxidize into a carboxylic acid because it's taken out immediately as it forms by evaporation. So we know we have an aldehyde formed because we haven't let it further oxidize into a carboxylic acid. So what if we want the carboxylic acid? So first we add our oxidizing agent, our acidified potassium dichromate, to our primary alcohol and we reflux it. And this is our reflux apparatus here. So refluxing is heating with a condenser directly above our pear-shaped flask, so down here. So our product evaporates, condenses in our condenser directly above, and so simply recollects in the reaction mixture to keep reacting. So our product will evaporate, but it will just condense in the condenser and fall back into our pear-shaped flask to continue reacting. And reflux is a way of heating a mixture without losing any solution due to evaporation. And this is because if a product evaporates, it will just condense back down into here. So no product is lost. And this is done so that when the aldehyde evaporates due to the heat when it's first formed, so after our first oxidation, our aldehyde evaporates, but it cools and condenses in our condenser and simply drops back down into our reaction mixture to continue oxidizing into a carboxylic acid. So after our first oxidation, our aldehyde will form, which will immediately evaporate because of the low boiling point, but it will recondense in the condenser and fall back in to our reaction mixture to continue to oxidize with our acidified potassium dichromate to form our second oxidation reaction into a carboxylic acid. But our carboxylic acid doesn't evaporate because it has strong hydrogen bonds. So now we're going to look at primary versus secondary oxidation. So you can determine the type of alcohol oxidized by its product. So if the product of an oxidation is an aldehyde or a carboxylic acid, we know that the alcohol we started oxidizing was primary. And if the product of our oxidation was a ketone, then we know the alcohol we oxidized was secondary. So how can we determine whether a product is a ketone or an aldehyde to determine what type of alcohol we first oxidized? So the first test to find out whether it was an aldehyde or a ketone as our oxidation product is oxidizing with acidified potassium dichromate, so our oxidizing agent. So this is our first test to find out. And we know that an aldehyde will further oxidize with this acidified potassium dichromate into a carboxylic acid, because we know that in excess oxidizing agent, our aldehyde will further oxidize into a carboxylic acid. However, a ketone will not further oxidize because it cannot. So, if we have our aldehyde plus our oxidizing agent, our acidified potassium dichromate, we will form a carboxylic acid. And we know that this is a colour change of orange to green. However, our ketone plus our acidified potassium dichromate forms no oxidation product because it cannot further oxidize. So there is no colour change, it remains orange. So this is a way of identifying an aldehyde from a ketone. So if we add acidified potassium dichromate to our oxidation product and there is a colour change of orange to green, we know that our product was an aldehyde. But if we add acidified potassium dichromate to our oxidation product and there is no colour change, it stays orange, we know that our product was a ketone. So what is our second test for aldehyde versus ketone? And this is oxidizing with failing solution and heat. So we know that our aldehyde will further oxidize into a carboxylic acid, whereas our ketone cannot further oxidize. So our aldehyde plus our failing solution will form our carboxylic acid. And so the colour change will be blue from our Cu2 plus ions to a brick red for our Cu plus ions. Our aldehyde has been oxidized, so it has got this colour change of blue to brick red. Whereas our ketone plus our failing solution has no oxidation product, so it will remain blue because there's been no oxidation. So this is another way of determining an aldehyde from a ketone, because if there is a colour change, if it does turn blue to red, we know that our product was an aldehyde because it can further oxidize. And what is our final test for our aldehyde versus a ketone? And this is Tollens reagent. And Tollens reagent is silver ions in a ammonia solution. And we know our aldehyde will be further oxidized by this Tollens reagent, whereas our ketone will not be oxidized by this Tollens reagent because our ketone cannot go on to further oxidize. So if we have an aldehyde plus our Tollens reagent, it is oxidized into a carboxylic acid. So our colour change will be colourless for our silver ions, and it will change to a silver mirror, so a silver coating. So you can see here our colourless to our silver mirror. So this is a clear change. It's further oxidized into a carboxylic acid, and we now have the change to show that. Whereas a ketone plus our Tollens reagent will form no further oxidation product because it cannot further oxidize, so it remains colourless. So another way for determining an aldehyde from a ketone is adding Tollens reagent, and if it goes from colourless to a silver mirror, we know that it was an aldehyde. If it stays colourless, it was a ketone. So all of our three tests that I've mentioned are determined by whether the product can be oxidized further by another oxidizing agent. So if our product can be oxidized again, that means we had an aldehyde, so our original alcohol was primary. If our product cannot be oxidized again, that means that it was a ketone, because a ketone cannot be further oxidized, so our original alcohol was a secondary alcohol. And here is a summary table of all of our tests and our colour changes to show whether it was an aldehyde or a ketone. And you can see that for an aldehyde we have all positive colour changes, whereas with a ketone the colour stays the same, there is no change.